My name is Andrey Fadin, Product Manager of the Kaspersky OS and Kaspersky Transportation Security teams. In this demo, we will be describing the features of our Kaspersky Automotive Adaptive Platform, leveraging multi-level security and secure over-the-air updates (OTA) for automotive electronic control units (ECUs). The last decade has seen a number of car hacking studies focusing on diverse attack vectors such as vehicle, near the vehicle, and remote attacks utilizing connected vehicle backends or driver mobile apps. Advances in IT, together with continuous innovations, have brought new challenges. Because almost all the vehicles are now connected, a holistic approach is needed to protect against attacks on every area of vehicle ecosystem. Without a doubt, one of the hottest topics in the industry is that of upcoming regulations. UNIS R155, R156 to be precise. These are important deadlines in 2022 for new vehicle types and 2024 for new vehicle compliance. Failure to meet these regulations will mean vehicles cannot be homologated, bringing production to a halt. Kaspersky has been working in the transport sphere for more than 5 years. A dedicated division has been set up, especially for this purpose. We now have a broad range of the transport-related offerings, including our existing portfolio for mobile apps, cloud infrastructure security, and a suite of tailored services and in-vehicle solutions. We offer a suite of automotive compliance services and are ready to help you at every stage, starting with the cybersecurity concept, followed by thorough analysis, and ending with the cybersecurity assessment. Our tailored threat intelligence reporting service helps you get all the info regarding existing security researches, vulnerabilities, incidents related to all your ecosystem components, including supply chain. We crawl public resources, including forums, chats, and dark web discussion boards and other private communities. We are also ready to run a penetration test on any part of your ecosystem, including ECUs itself, backend services, base transmission stations, and mobile apps. Our professional team is capable of doing both the paperwork as well as the technical stuff. With respect to in-vehicle security, we tend to encounter two general situations. The first is when an automotive maker or supplier is building a new architecture and a new electronic control units for it. For this, we offer Kaspersky Automotive Adaptive Platform, based on our Secure by Design Kaspersky OS, which already has a number of built-in tailored security controls, such as secure boot, over-the-air update, and so on. The second case is when an automotive company wants to enhance the security of an existing ECU, for which it has already chosen operating system, middleware, and other architecture solutions. In this case, we offer our Kaspersky Secure software module for ECU. It's an intrusion detection system that's ready to be integrated into Vehicle Security Operations Center. The evolution of electronics and electrics architecture has transformed the way ECUs are developed and used. Today, the automotive industry is bringing new use cases to modern cars, such as advanced driving assistance or even autonomous driving, vehicle-to-road, vehicle-to-vehicle communications, and digital dashboards that provide a rich user experience. These scenarios require complex software engineering, continuous over-the-air updates, safety, and reliability all at the same time. To meet these challenges, the automotive industry proposed the AutoSAR adaptive standard, leveraging service-oriented architecture. It will help automakers focus more on features development than hardware and bus routines. It will also support the current trend of ECU consolidations, whereby dozens of simple microcontroller ECUs are replaced with several high-performance controllers. These controllers are capable of running multiple automotive applications with different safety requirements and integrating all of them with the AutoSAR standard. For these types of ECU, we offer our AutoSAR platform. What do we offer? An automotive platform built on the Secure by Design Kaspersky OS and then leverages the latest AutoSAR adaptive standard to bring service-oriented architecture. This platform is coupled with over-the-air update system (OTA) based on the Optane standard and Vehicle Security Operations Center communication. All of this will help to meet the cybersecurity requirements of the upcoming UNIS and ISO 21434 regulations. How do we differ from the competitors in terms of security? The main difference is strong isolation of all internal components with unified inter-process communication and dedicated policy decision and enforcement points. To achieve this, we built our own microkernel operating system from scratch, following Mills and Flask architecture approaches. At the heart of this design is Kaspersky Security System, our patented policy engine that gives you flexibility to define granular policies tailored to your subject area. For instance, for example, in the context of the automotive industry, access could depend on certain ECU states, vehicle speed, engine temperature, etc. We have various predefined policy models such as role-based access control, object capability model, temporal logics flow, and etc. Our solution in SDK is capable to run as Docker image or natively in Linux, Windows, WSL. This SDK provides environment for adaptive apps development and the building of the final image to be ported to ECU with our operating system and middleware. A key element of our platform is the porting tool that simplifies the porting of existing Autozar adaptive apps and integrate them into build chain. Or we can help out by offering our porting services as well. You receive our SDK and use our porting tool to adopt your CMake files and update a final image of middleware and OS. This demo depicts an advanced driving assistant unit for a car connected to external sensors such as camera and is running Kaspersky OS with our Autozar middleware on it. On top of the stack, there are Autozar applications provided by our automotive partners, for example, AVL, software functions, or Ubiquiti. These applications implement a particular business logic, for example, road lane detection or autopilot mode. Let's create a short sample with the OpenCV application for ADAS ECU for lane detection. Our demo is based on an automotive-grade Renesas R-Car H3 development board equipped with camera sensor. The camera is pointing to the screen depicting a moving road. The ADAS application on our dev board is processing this input and the output is displayed in the second window. For the sake of simplicity, it will only show the result of the lane detection routine, nothing else. So let's start our first ADAS app. Okay, it's working. The detected lanes are depicted on the screen. So we now have a very basic working function. Next, we will show how it can be remotely updated over the air. This is important for new business functions or when fixing bugs or mitigating vulnerabilities. Let me hand over to our major auto partner, Ubiquiti. Rajan.
Thanks, Andrey. Hello, everyone. My name is Rajan Chaudhary, and I'm a product manager at Ubiquiti responsible for automatic software management product. Ubiquiti has been around for more than 20 years, and during that time, we have worked very closely with multiple automotive OEMs and tier ones. Our automatic product is an industry-leading multi-ECU OTA solution that securely orchestrates and automates software update campaigns while also meeting the unique regulatory and security requirements of the automotive industry. Automatic is also compliant with the Uptane security framework, which is currently considered the de facto secure standard for software updates on automobiles. Now I will walk through our automatic B2B administrative portal, and this is the portal that an OEM administrator will use in order to create campaigns. Here you can see we have a list of campaigns already created for different vehicle lines. I'll go ahead and click on New Campaign and give it an appropriate name and description. Next, we will select the regions and vehicles that this campaign will be targeted to. And once that's done, we can select the packages that need to be delivered to the vehicle for this campaign. Localization info and campaign policies related to the priority of the campaign, and also whether we need to get consent from the customer for the download and installation of updates can be set as part of the campaign creation process. Finally, we can review all the settings and parameters of the campaign, set the release date, and submit the campaign for approval. Now, once the campaign is approved and the vehicles are being updated in the field, we can look at reports of how the campaign is doing and how many successful installations have been completed. Here you can see the different components that we provide and will be seen in the end-to-end demo that Andrey will show you. This was a quick overview of our automatic software management product. Back to you, Andrey.
Thank you, Fadin. Just a few words on how it looks from the point of view of the vehicle driver and the ECUs. The ADAS ECU checks the updates from the backend on a regular basis, and after the auto campaign has been started, it asks the driver's permission via infotainment HMI to start the update process and start it once it gets approval. In our case, an updated version of the computer is deployed to the board. For the simplicity of this demo, we will only change the lane detection color, but any code and configuration update is possible. Would like to mention one particular example of successful collaboration, AVL software and functions, where Kaspersky Automotive Adaptive Platform was fully integrated into AVL, a unique ADAS unit. As a result of that collaboration, Kaspersky Automotive Adaptive Platform currently supports a unique basic ECU from AVL. It's an open ADAS platform ready for various use cases. Thank you for your attention. We would be happy to answer any questions, and please see the additional info below.